This lesson, we are going to discuss the steps to find capacitance. How can we find capacitance? So we can find that in 4 simple steps. The first step is, we'll assume a charge Q on the plates, plus Q on the positive plate and minus Q on the negative plate. Next step is to find the electric field. So we'll find E vector. Once we have found E vector, we'll find V, the potential difference between the plates. And then capacitance is given by Q by V, because Q equal to CV. As simple as that. Let us discuss a parallel plate capacitor. Parallel plate capacitor. So this has got 2 parallel plates separated by a distance d. So now we have to assume charge Q on the plate. So plus Q charge here, minus Q charge here. And let sigma be charge per unit area. So this plus Q is plus sigma into the area of the plate, and this is minus sigma into area of the plate. Both the plates have same area. Now, if this is the situation, we know how to find electric field. Electric field is from plus plate to minus plate, and its magnitude is sigma by epsilon naught. So 2 steps are done, as simple as that. And now this electric field is uniform. Now in uniform electric field, V is given by E into D. So the potential difference between the plates will be E into D. And once we have found V, now we can find C. C will be Q by V. So Q by E into D. But E is sigma by epsilon naught, and Q is sigma into A. So sigma into A by sigma by epsilon naught into D. Sigma will cancel out and we'll get epsilon naught A by D. This is the formula for capacitance of a parallel plate capacitor. Very important formula. C equal to epsilon naught A by D. Now, if you want to build a capacitor with large capacitance, we have to increase A, the area of the plates, and we have to decrease D. Then capacitance will increase. Now capacitors that we get in the market typically look small, but actually inside them the area of the plates is very large. Let us assume that this is one plate, this is the other plate. Now if you keep this plate on this, then the area of the plates is large. This area is large. And the distance is small. The distance can be made fraction of a millimeter. Okay, we need to put an insulator that we'll discuss later, that is called dielectric, between the plates, and the distance can be made fraction of a millimeter. So now these 2 plates are there, one on the other. So capacitor, the parallel plate capacitor, will look like this. Now how to make it look small? So then we can roll this. So this is rolled like this. So this is rolled. And once we roll it, then it becomes a very small looking capacitor. But actually inside that there are 2 parallel plates with large surface area and very small distance between them. Even this rough case, now it looks so small. So this is how we'll build a capacitor with large capacitance. increase the surface area of the plates and decrease the distance between the plates